Okay, sound test. One, two, one, two. Sound check. One, two, one, two. Sound check. One, two, one, two. Um, Good day, good day, good day, good day, good day. And today we're looking at differentiation again because someone asked me to do the following question. So I decided, like, you know what, let me just do everything. Let me just go live so everyone can see how these questions are done. So these are the questions we're supposed to be doing today. Like I say, it was someone's request. Let me just get my phone so we can proceed. Okay, so um, differentiation, right? I feel like there's a lot of videos that I've made regarding differentiation in the past few months, weeks or so. Um, if you follow most of the videos that we upload on our YouTube channel, either should be also here on Facebook, either should be Twitter, and so forth and so forth, you may see that there is some video that we have done regarding differentiation. But before we start looking at the questions, which are these, before we look at these questions, I just want us to go back and revise how to differentiate. This one, I'll do it quicker to a point where if you feel like you won't understand properly on this one, you can just go search on our social media platform, search for differentiation video, something like that, and you'll find where I explain stuff into detail. But for now, we're just gonna go through with what we have. So let me show you the basics of integration. I mean differentiation, which is integration is the reverse though. So like it's better to understand it's one end of the other, but then it's fine. So if you have a function f of x is equals to a x to the exponent n. If you have a function f of x is equals to a x to the exponent n, they may ask you to say calculate the derivative or find the the differential. So it's normally just x prime x. We denote it by x prime x. So to find x prime x, we said this is how it works. Um, the exponent, you move it from where it is and then you multiply it, you put it in front here, and then you multiply it by whatever constant it may be there. This is a constant number. It could be 5, it could be 2, it could be 3, it could be whatever number it may be. Even if it's a variable, it doesn't really matter. But then now we are we are differentiating this variable. So that's when the n, you move it to the front, you multiply it by whatever that is in front of x. And then the next step is you also subtract 1 on that very exponential value. So n is also going to be a number. So we say the differential of this is equals to f prime x will be n multiplied by a x n minus 1. This is how it practically works. In reality, of which, there's no reality as such, as mathematics. But then to picture this in the form of an empirical number that kind of makes sense, we can think for a case where we have f of x is equals to 3x to the exponent. I can even choose 4, right? So the rules say if I want to differentiate this, or if I want to get the value of f prime x, it's going to be the exponent I multiplied by what is at the front. So it's going to be 4. I move it from there to this side. It's going to be 4 times 3x 4 minus 1, n minus 1. So I move the n to the front. Now, moving the n to the front. So this n, I've moved it to the front. Now it's there. And then I multiply it by 3x to the exponent. Then the very same 4, I subtract 1 from it. That's n minus 1. Like I say, if you don't get this, there's a video where we explain this into detail. If you want to go look at this, you can just stop from here, switch to search for the video where we're talking deeper and deeper about differentiation, and then you go check it from there. But for this case here, this is the revision class. We are preparing for exams. So now I feel like through this information, if the information is valid enough for us to can attempt the first question. That's how I see. Because the first question is this. They want us to differentiate that value there. Let me just zoom it for myself. So it's f of x minus 2x cubed plus 3x squared. So if you can't see it clear, let me just, if you can't see it clear, I'll write it down here on my board. So here we are given here we are given here we are given f of x is equals to minus 2x cubed plus 3x squared. And then the very same rule. Like you think of this term as a term of its own, you think of this term as a term. So we have two terms, this one and this one. And then how we do it is we differentiate the terms individually. So this is how it's done. F prime x is going to be the first one, the exponent is 3. I'll take the exponent to the front and then I multiply it by minus 2. So this is going to be 3 multiplied by minus 2. Consider the sign as is, and then it's x into 3 minus 1 because I have to say n minus 1. Then we come to the next term. Plus the 2 comes in front, and then it's going to be 2 multiplied by 3x 2 minus 1. I can even put this in bracket if you want to ask yourself, why do I put in this one? Why am I putting this one in brackets, but not this one or whatever? Or some people, they call them parentheses, but then, yeah, man, why do I put this? Like I'm from Pushback Ridge, we refer to this as brackets. Why do I put these ones in brackets, but not this? Bracket means multiplication, but the reason why I used brackets is because of the negative sign. I believe this is a mathematics related topic, so otherwise some questions are not relevant unless if it was a grade 9 lesson. But otherwise, I don't like to assume that people understand because sometimes you don't know what you don't know, whether it should be yourself or about people. Anyway, this will yield, okay, so now it's 2 times 3. Don't get that wrong. So whether I put it in bracket or I just put a multiplication sign there, it doesn't really matter because it's a positive. But then the bracket here represent a negative. Otherwise, I can just put a multiplication sign there with a negative, but it gets to be confusing on whether the negative is a minus, because there's a minus and there's a negative, as you know it like that. But then now breaking this one further, um 3 times minus 6, 3 times minus 2 gives us minus 6. X to the exponent 3 minus 1 is 2. And then here also we have 2 times 3, so that's going to be plus 2 times 3 is 6 into x 2 minus 1, and then it's that value. So we don't necessarily even have to write the 1 because any number is to the exponent 1. So 2 minus 1 is just, we know that any variable, it is that invisible one. They call it invisible one, but then we know that it's actually something that is there. So here, the question, it was only 2 marks. So for 2 marks, this is what you do. But then the explanation has to be like a bit brutaliana, so you can get the marks in full. But for an average someone, I believe now the secret, like I say, is just to follow the rules. And following the rules means you just have to stick to, well, I would say stick to what you know, but yes, you follow the rules because you have to know them first. And the reason why I say you have to know them first is because there is a video, like I say, there are some videos where I made and I was explaining my lungs out how to differentiate. So I come with everything in order. And the nice thing about the technology that we have these days, it's no longer those olden days when we used to watch these things on TV. Now we can pause, can go back, screen grab, whatsoever. But yeah, so if you want to understand more of that, but then otherwise, the first question, this is how it's done. We do it like this. So I feel like maybe for now we can move to the next question. But before we do, there are some things I need to explain regarding the question, the way I look at it, like the way I look at it now. There are some things we have to add on, some information, which also there is a video that I've done, because mostly differentiation regards like it has something to do with exponents, like a lot. It's a lot of exponents involved. And there's a video where I've done explaining the rules of exponents. The reason why the rules of exponents are important is because they get to a point where they explain a whole lot of things. The rules of exponents, they give us a theory of how a square root is, how to treat a square root, how to treat fractions which with exponential values. Let me just go back to this slide here so I can explain. Yeah, let's look at this. According to the rules of exponents, or according to the rules of any other if you have square root of x, we say this is the same as x to the exponent 1 over 2. This you must know, it's a rule. By definition, it's something which you must always remember. If you have a square root of x, this is the very same as x to the exponent 1. Rule. Again, if you have 1 over x, say squared, for instance, whatever value, if you have a fraction and then it states 1 over x to the exponent, whatever value it could be to the exponent 2, it could be to the exponent 3, it could be to the exponent a million. According to the rules of exponents, you're allowed to write this like this. So technically just put it upside down and then you change the sign of the exponent into a negative. But this should get us somewhere. If this applies, it means also if you have a case where you have x over um x over 1 to say to the exponent whatever value it may be, but then it's a negative now, then this is the same as x to the exponent positive 3 of that value. Again, this is a rule which you must know according to the rules of exponents. It's exactly the very same way as this. You'll see how this will help us answer the following question that we are going to right now. Let me add just one more last one, just to make sure we are on the same page. So from the ones that I've just explained now, if this is equals to this, then I'm certainly sure that if I have 1 over square root of x, I'm certainly sure that you can buy it if I can say this is the same as x to the exponent negative 1 over 2. And I would like to ask, why must we say this is like this? Why so? Because we know that this here is the same as 1 over x to the positive 1 over 2. But then now, if I want to remove the fraction and put it properly, that's when it's going to become this. You see, so everything everything makes sense like that. That's how it makes sense to the world if you follow the rules. I think with this information, we can be ready to tackle the next question. And then I think by this, I would have answered one of my students' question regarding the two questions that they sent me. So here we have this one is our next and final question. I'm just going to write it down so we look at it in a so the question states dy over dx they want us to determine the dy over dx if y is equals to 2x plus 1 over square root of 4. Now, I think you do understand where this is going based on the explanation I've just done before we start the questions. And now we're just going to do this one. We're going to go straight to point. Again, we have two terms. We have this term here, and then we have this term here. This term is fine. We can go ahead and differentiate it as it is, applying that we know that is to the exponent 1, is to the exponent that invisible 1. So the 1 will come to the front, and then we'll multiply by 2, and then x to the exponent 1 minus 1. This one is fine. But then this one, it's a bit complicated, Nyan, and we must try to put it in this form, right? So now that's when we apply what I was showing you right now. To simplify this term, Ili1, we can just take the term Ili1 and try to simplify it. Let's zoom it microscopical. So we have 1 over square root of 4. I don't think you're going to fight with me as a grade 12 student if I can say this the same as 4 times x because it's 4x, right? And this the same as 1 over square root of 4 square root of x. I can still put the times there. And then clearly you can see this is 1 over 2 square root of x. So basically, 1 over square root of 4x is the same as 1 over 2 square root of x. And this is how you derive it if you don't believe me. If you don't believe me up until now and then, by definition, you just have to go back and try it on the side. If you don't get the same answer as me, then something wrong. So I'm going to take it from here and then I simplify this one further. Okay, I can remove some of the stuff we don't need. The nice thing is that the video, whether I'm live now or later, or you watch this later on, you'll be able to reverse and go back to what you'd want to see. So I can just write it here. 1 over 2x. 1 over 2 to the exponent, 1 over 2 multiply, 1 over 2 square root of x, yeah, man. So when I simplify this further, it's still part of me simplifying this. So this is going to be, if I simplify this further, I'll have 1 over 2, maybe I can say multiply by 1 over square root of x. We understand this, right? It's a times here. And then this is the same as 1 over 2 multiplied by 1 over x to the exponent 1 over 2. Remember what I've just stated previously. And this is the same as 1 over 2 x to the exponent minus 1 over 2. And then this here is in the form where like, now I can differentiate this. So basically what I mean is, from the simplification that I've done right now, it means that y is equals to 2x plus 1 over square root of 4x. It's the same as y is equals to 2x plus 1 over 2x minus 1 over 2. The way I've simplified it on the previous. So I've then simplified this term for you from the previous explanation that we're doing now. So meaning from here, we can go ahead and find the derivative. Now, the derivative, the previous time we were looking at f of x and then we said f prime x. Live videos. I'm busy talking, but I'm not writing, but then it's fine. Let me just explain what I was explaining again, because I never wrote anything down. It's live anyway. We have nothing to lose. You can keep on reversing and go back to where the video started. I said here, they want us to find dy over dx if y is equals to this. And dy over dx is a derivative. There are different forms to find the derivative. They can say y prime, they can say dy over dx, they can say f of x prime. Like I say, there is a video where I'm explaining these things into detail. So for now, for this first term here, we can find dy over dx. It would be easier to differentiate this, but we have to simplify this using the information that I explained. So I said 1 over 4x, this is the same as 1 over I can skip a step there and just put it like this. This is the same thing. And what does this mean? This means that this is the same as 1 over 2 to the square root of x. And what does this mean? This means that this is the same as 1 over 2 multiplied by 1 over square root of x of some sort. And what does this mean? This means that this is the same as 1 over 2 multiplied by 1 over x to the exponent 1 over 2, like I explained. Let me just squeeze this part here so it can be visible to the screen. 1 over 2 into, because square root of x is the same as x minus, no, square root of x is the same as x to the exponent half. And then now the final part would be, this would be exactly the same as 1 over 2 x to the exponent negative 1 over 2. So basically what this means, it means that this part here is the same as this part here, 100%. So from here, we can just, I can remove this and explain to you, because the previous time is just that I was not writing anything down, hence I had to start afresh with the explanation. So this then implies that if I have y is equals to 2x plus 1 over square root of 4x, this is the same as y is equals to 2x plus 1 over 2x minus 1 over 2. And then from here, I can go ahead and differentiate and find my dy over dx. So dy over dx is going to be, for this one, 2 to the exponent x, there's an invisible 1 there. And then to apply the rule, the invisible 1 will come in front, and I multiply it by 2, and then I subtract the very same value there. So it's going to be 2, 1 times 2, x, 1 minus 1. I would say plus, but look at this. I'm going to bring the minus half to the front. So it's going to be minus 1 over 2 multiplied by this 1 over 2, x into minus 1 over 2 minus 1. You get it? N minus 1. Minus 1 over 2 minus 1. Therefore, this is going to be 1 times 2 is 2. 1 minus 1 is 0. X to the exponent 0 will be 1, because anything to the exponent 0 is 1. So this is just going to be 2. But then minus 1 over 2 times 1 over 2, this is going to be minus 1 over 4 x minus 1 over 2 minus 1. This one, you can just quickly do it separate if you want to understand. So this is how we work it out. We would say minus 1 over 2 minus 1. If you take a common factor there, it's 2. 2 goes once into 2 multiplied by minus 1. It's going to be minus 1. This one is over 1. 1 goes twice into 2. 2 times minus 1, it's minus 2. Therefore, this is going to be minus 3 over 2. This means that here we'll have minus 3 over 2, because minus 1 over 2 minus 1 is a fraction minus a whole number. So this is how you differentiate. So this is our differentiation. This is our differential. This is our dy over dx. I don't think that was so hard, right? I think it was actually more applicable if, like I say, you follow the rules. So the secret is just to follow the rules. I say this in each and every video that I make, but now, like I say, I've discovered I think now the quality of the voice, or rather the audio, is better, such that we can do more live videos now. And live videos, they are nice because you get to send your comments and you get to say some stuff that you want to say. And yeah. So for now, I think this one, we're just going to stop here, because we only had these 2 questions to do. And I will schedule more videos in future from tomorrow. All you need to do just to catch up is to know, okay, basically what we'll be doing is we'll be doing a lot of past question papers for matriculants, grade 11 students, and grade 10. And then roughly we'll be doing first year stuff like for maths and physics and accounting and economics here and there. But then now, to catch up on all of those, you just need to subscribe on our YouTube channel, so you can also, after you subscribe, then you press the reminder button, so you can get more rather, you'd be reminded, you can watch the videos. And then you can follow us if you're watching from Twitter, X, since it's X now, from Facebook. You can also just follow us there. Otherwise, this is simplified RSA. The guys makes it looks easy. So we're out here making things looks easy for everyone so that the exams can be better for this year. So we can like reduce the 33.3% pass rate in South Africa. Oh, okay. Maybe I shouldn't say that. But we just have to improve our marks and do better. I'm Mr. My money and it's so hot in here. So because of that, I have to go out.